going to work one that involves an absolute value. We're going to go from -1 to 1 of the absolute value of x dx. Let's draw a picture. We will color our graph. We'll give it a purple color, let's say. I'm not exactly sure that's exactly the graph of the absolute value of x, but this is right. I think we're a little too low here, but that's okay. We are going from -1 to +1. And remember, you can think of this as finding the area under the curve. Now this is supposed to be a symmetric picture. In other words, a reflection about the y-axis, but it doesn't look quite that way, but it is. We're going to have to break this up into two separate integrals, going from -1 to 0 and then from 0 to 1. If I were to write this out, and we wanted to write this as a piecewise defined function, we would say, okay, that's supposed to be the absolute value of x. We would, and that's supposed to be a curly bracket anyway. X is, x is, yes, less than 0. X is less than 0. And x is, ooh man, x is greater than or equal to 0. I'm just all over the place here. This defines right here, if we looked at our graph, so the piecewise function, right, defines this absolute value of x. And this is what we're going to be using, this part here. And I think I'll just rewrite this. -1 to 1 of the absolute value of x dx is equal to the integral going from -1 to 0 of -x dx. That would be this top part, the piecewise function, plus, and then we're going to add, going from 0 to 1 of x dx. We had to break up this absolute value function, and hopefully you understand why now. And then we just evaluate each one of these separately. And let's do that. -1 to 0 of -x dx is equal to, hopefully you have caught on at this point, -1 to 0. Right, we add 1 to the exponent and take the exponent and put it down below. Well, we do the upper bound first. We end up with just 0, because plugging 0 in for x, you get 0, minus, make sure you start a parentheses here now, plugging in -1, -1 squared over 2. -1 squared over 2. And this becomes, let's see, 1/2. This is a half, makes it negative, and positive, so that becomes a half. Good enough. And then why would you even do the other part? Go through all that, right? Because you know, because our picture is symmetric, that it should be a half also. dx is equal to, but we'll do it anyway, x squared over 2, going from 0 to 1, plugging it all in, and we get a half. Therefore, we have a half plus a half, and it should all equal 1. You could also look at this geometrically. Well, this is just a right triangle, and to find the area of a right triangle, isn't it a half times the base times the height? So this would be, oh, I said the word so. This would be 1 and 1, and 1 times 1 times a half is a half.